it is my pleasure to introduce to you Dr. Simon Poole. He received his Order of Australia in 2018 for contribution to photonics in Australia. So with over 40 years of experience in optics and photonics, including being one of the founders of EDFA, which is Erbium Doped Fiber Amplifier, he's really revolutionized what photonics looks like in Australia. He's been a part of many startups, including JDS Uniphase, Finisar, which started out as Engana, and also Silite, two of which we'll hear about tonight. He also contributed to a report last year, which I invite him up now to talk about.
Right, so let's see how this all works. All right, is this thing working? Do I have to hold it there or up here? There's good. All right, fantastic. I'm not quite sure about cleaning my beard with this. What can I? Oh, let's see if let's see if this thing works. Let me know if the online people can still hear. Does that work? Yep. Okay, I'm talking about spectrum scan today. I'm sorry about this, Sydney. Whilst we're sorting that out, I just would like to thank Sarah and Katie for setting this up. It's fantastic that we have people like this really wanting to get people together from industry. It's something that's been something I've wanted to achieve for a long time. It's been quite hard to get happening. So having two really enthusiastic people to drive this from the ground up is fantastic. So thank you very much to both of you for setting this. Okay, whilst we're getting slides, I'll just, yes, there we go. We're getting started. We've got the slides. Let's see if this thing goes forwards and backwards now. Yes, it does. All right, we're in business. So this is a presentation where I'm going to talk about a fairly high level view of the photonics industry in Australia and in New Zealand. Before we get into that, I really want to thank a few people, John Harvey and John Lincoln, who did the survey and report with us. John Harvey's with the Dodd Wall Centre in University of Auckland in New Zealand. John Lincoln is a consultant out of the UK who's done a number of these reports for different countries. He's done it for the UK, he's done it for Scotland, he's done it for parts of the EU. And also thank the people who put the money in to pay for this, the AOS or Australian New Zealand Optical Society, I think it is nowadays, SPIE and the Dodd Wall Centre for Photonic and Quantum Technologies in New Zealand. They paid for this. So the reason that we started to put this together was to try and get an understanding of what does the photonics industry look like in both countries. There's a pretty good understanding of what the research university base is like. There have been a number of reports over the years about capability in research and so on, but none where we've actually looked at what has photonics contributed to the economies of both countries. Typically and historically, both countries, both Australia and New Zealand, have been driven by natural resources. In Australia, it's mining. In New Zealand, it's cows. But those of us in the photonics space realise that there's more to life than digging up coal and selling milk, which are the two sort of primary things here. And we really want to be linking also the science and research that exists within the universities. We have a great capability there, linking that more into outcomes, making sure that we're getting the benefit of that for society. What's very difficult in doing this is that unlike the university sector where everything is basically tabulated and people know where the money's going, what the research programs are, who's doing what, within the photonics industry, there really isn't that knowledge. There is no knowledge of what different companies are doing, even who's in the industry. It's very hard to find that out. And so what we try to do here is not to provide a complete historical record, but just to do a snapshot of the industry as it was at late 2019. And the aim is to take this, and every 2 to 3 years, we'll retake that snapshot and we'll see how we evolve over time. So putting this in some context, These are the exports by sector from Australia in the top left and New Zealand at the bottom right. Photonics sits in these blue sections. It's part of that in terms of our exports. What will be interesting as we go through this is we see that photonics is generally consumed within the countries rather than exported. We're not big exporters of photonics, but as you'll see, we generate a lot of activity, commercial activity of photonics within the countries. And you can see that one of these somewhere in here is photonics, and it's almost infinitesimally small compared to, in Australia's case, all of this stuff that we dig up and sell. And in New Zealand's case, all this stuff that comes from cows. It's even smaller than the wine exports in New Zealand. So we're talking now about trying to pull out and distill what that is. So what we've got to do first of all is define what is the photonics industry that we're talking about. And the definition that we use is the one that's been used by SPIE in their surveys and the EU in their surveys. It's companies manufacturing systems and devices using light-based technology together with the service industries deploying and supporting these technologies. So it's a fairly broad brush description, but it's trying to capture all of the economic activity related to photonics. So it includes the design and the hardware, but it excludes all of the research activity. We're talking about the industry part here, not the academic part. As I say, that bit's well known, well understood. We know how much the ARC spends in the optics codes each year. That's easy to find. And to do this, let's try and understand the photonics value chain that we're working in here. We start off with photonic components. This can be lasers, it can be pieces of optics, it can be lenses, it can be detectors, it can be optical fibers. All of these things count as the photonic components, which are then integrated into photonic products. You take a laser, you put some lenses on it, you put it into a transceiver, you then build that transceiver into a much larger piece of communications gear. Or in the case of Baraja, you start putting it together with the electronics and signal processing to allow you to build a LiDAR system. Then you come on to products which are enabled by photonics. So this is something like where you've got a camera and you're using photonics to adjust the lens section of a camera. So you've got a product which wouldn't work without photonics, but it's not just about the photonics. And then finally, right at the top, you've got all the services enabled by photonics. And this is the biggest chunk of the whole thing. If you think of this, basically the internet wouldn't exist without optical fibers. The internet and all the services that are based on it do not exist without photonics. And the overall market for these photonic services and products is around $10 trillion a year. That's coming out of numbers from the SPIE from a couple of years ago. So we're talking about photonics underpinning a massive amount of the global activity. And we sort of know that because we all think that photonics is wonderful, because that's why we're here, but it's not generally recognized just how important it is as an underpinning technology for so much that we do. So that's what we're trying to tease out here, is what exactly are we talking about with this? How does it apply into the industry that we know? And there's a few problems in doing this. One, there are no industrial classification codes for photonics. Well, you go, okay, what the hell does that mean? The government understands how a country's economy works by looking at the economic activity in different sectors. So it looks at, how much there is in mining, how much there is in manufacturing, how much there is in winemaking, my favorite, and assigns a code, somewhere between 5 and 8 digits, depending on how detailed they're going, to that activity that says, this is the activity of photonics, and it's got this code 1, 2, 3, 4, 5. Unfortunately, there is no code for photonics. As we'll see later, there are 2 very small codes about photographic equipment, but that's it. The rest of photonics is covered under manufacturing other. So we're sort of stuck down there as unknown manufacturing. There's even codes for shoe leather which exist, but not for photonics. That's the sort of ingrained historical stuff we're trying to deal with here. Another problem is that for many companies, they're not all about photonics. You look at a big company like Thales, defence contractor. They have a significant photonics capability, but that's a very small part of their overall business. So when you think of Thales, you don't think of a photonics company, you think of defence contractor. It's also very diverse. And when we came to trying to get our arms around what this industry is like, it was really hard because the people involved in putting this together, they're coming from the high-tech end. I'm out of the sort of the optical fibre, telecoms business. John's out of lasers and quantum photonics. But we have to bring into this all of the people who are designing lighting, because lighting is photonics. And there's a whole industry in Australia around designing specialised lighting. We think it's just changing the globes or sticking an effervescent tube, but there's a lot more in there, which is value-add photonics engineering in Australia. And then you've got the hidden technology. This is, as I said earlier, companies operating in many vertical markets that you just don't think of as photonics companies. And we'll see some of those as we go through there. Now, if there's any questions at any time, feel free to stick up a hand, interrupt, shout. If anything comes through online, let me know and I'll take questions as we go. So the way that we get around this is to look at a slightly complex methodology that we've been used by the UK Photonics and Acoustics. It's been driven by SPIE globally. Andy Brown, SPIE, has done a lot of work on this as well. And I'll talk you through how we go through this so you can understand how we get that picture and explain a little bit more about how that industry is structured. So the survey was done by John Lincoln out of the UK. And John Harvey and myself assisted him in doing this because we were the local on the ground guys. He's the guy who knew how to drive all of the various databases we needed to access. And a really important part of the whole process, once we've worked out the companies, is this thing called apportionment. So when you look at a company like Finisar, for example, their entire business in Australia is based around photonics. That's really easy. Same with Baraja. If it wasn't for photonics, the company wouldn't exist. So that company is 100% photonics. If you look at something like Thales, they've got everything from planes through to rockets through to coding machines, also optical coding. They've got all sorts in here. How much of that turnover in Australia is optics based? We have to make reasoned estimates on that for all the companies in the ecosystem that we look. And so we had separate apportionment meetings where we looked at all of the companies that we had and said, we think it's somewhere between 0 to 10 or 10 to 30, 30 to 50 or 50 to 100% of their activities are photonics based. And it wasn't just John and myself. We've got a bunch of other people with expertise in different areas to help us here. To try and make sure that it was as accurate as possible, but it's always an estimate. It's our best estimate of what we see at the time. And then we went through that again a few months later, just to make sure that we hadn't screwed anything up badly first time round. And in October 2019, we froze the data and started doing the analysis and putting this report together. I've got a couple of copies. It's available online from the AOS website and a couple of other places. Help yourself to pulling that down and having a look. So this is the methodology. I said it was a bit complicated. We're going to split it up into 3 simple ones. Basically, we had to identify any company that we could think of that had something to do with optics. And there's lots of ways of doing that, as we'll talk about. We then had to refine it. Is it really doing optics, or does it just say it's doing optics? Is it value adding? Is it doing manufacturing? Is it doing something that creates value based on optics, or is it just selling as a distributor to somebody else? And then work out from that how much photonics output they had, how many people they were employing in the company in the photonics space, which we did as a proportion of revenue. And this thing called GVA, which I'll talk about a little bit later if I get a chance, which is basically the value add that the company is creating to the economy. So identifying potential companies, there's a whole raft of ways of doing that. There's databases of public databases of companies where you search for optics, photonics, optical, any of those terms, and just anything that matches, you just throw it into the bucket. You ring around all your mates and say, can you think of any companies in the optics space? Take the entire list that they give you, throw those all in the bucket. You then go through the SPIE, IEEE, and all the other databases you can find and pull out all the other companies you can find, throw them all the bucket. And then you have to go through and deduplicate all the records and find out, unique companies within that and work out whether they are suitable or not. In other words, yes, they may have the word optical in their name, but OPSM has the word optical in its name, but it's not really a value-add optical company. It's just a sales company for glasses. And from that, we then come up with this list of Australian and New Zealand companies. This is the refinement process. And then we go to a thing called Dun & Bradstreet, which is a credit rating agency. And what we do is we get from them the data about all of these companies. You have to pay for that, which is why we need money to do the survey. But they will tell you what their turnover is, how many staff they've got, and so on. So you can then build up a picture of what these companies are like. And from that, you then have to make a decision. Is this a user of Photonics? Does it actually do any value, or does it just take what it's given and use it? Is it a holding company, just a shell for commercial reasons, or is it manufacturing company, which is the sort that we're looking for, something that has value? And then you have to go through this process of, is it only Photonics? Yes, fantastic, that makes it easy. If not, we then have to work through in a sort of a fairly collegial manner. How much of this do we think is Photonics? How much of it is electronics? How much of mechanical? Whatever. And put a fraction of that in there and then repeat that for employment and profit, and then work out this GVA, which is the way the governments like to think about the economic value. And the numbers fall out a bit like this. So this is Australia and New Zealand, combined about $5.5 billion worth of photonics output in a given year. That sounds like a lot of money. It is a lot. It is a fairly large amount of money. There's roughly 12,000 people employed. There's somewhere around 600-ish companies, very hard to tell exactly. And the gross value add, which is basically the amount of value that the companies provide into the economy. It's the wages of the employees that they pay plus the profit that they make is termed the gross value add. It's the money that goes into the economy. So it takes out all the cost of goods and things like that would otherwise be in there. And when you start to run the numbers, you see that Australia is roughly 3 to 4 times what New Zealand is, which is roughly sort of pro rata in terms of population as well. And you don't think of New Zealand having huge photonics activity in there. You'd be hard pushed to name a global New Zealand photonics company. Can anybody name one? No Kiwis in the room going to shout their corner. Okay. Southern Photonics, Coherent Solutions. Yeah, they're okay. They're about 30 million a year, a lot less than the 1.2 billion. The Fisher and Paykel have got quite a lot of photonics floating around inside their kit. Fisher and Paykel, they make washing machines and ventilators and all sorts of domestic and commercial appliances. They use a bit of electronics. That's one of those hidden photonics. That's one of those hidden companies. They're the biggest manufacturing company in New Zealand, but they have a proportion of that, and they use a lot of photonics in their manufacturing. So there are companies that feed specialized photonics kit into Fisher and Paykel in New Zealand for their manufacturing. It's these little bits that we've been trying to capture. And when you put the numbers in, it's about 1% of manufacturing output is photonics based. It's not insignificantly small. It's not at the 10% level, but 1% of manufacturing within both Australia and New Zealand is photonics based. For Australia, that 4.3 billion is roughly the same to the manufactured output of the dairy industry, so all the cheese and yogurt and things that we make here. And in New Zealand, it's very similar to the wine industry, roughly the same size as the wine industry over there. So these dairy and wine have a very much higher visibility within both countries than photonics does, but photonics is of a similar size. So we have a visibility problem, which is kind of strange seeing your optics. But we have a visibility problem because there isn't a nice, easy way to group all of us together. We're all in different bits of industry. The other thing that's tricky in this is that in the photonics space, both in New Zealand, Australia and in New Zealand, most of the photonics companies are very small. So we've got a large number of companies, but they're mostly very small, few person operations doing special things. There are a few larger companies and they produce most of the revenue and employment, as you'd expect in both cases. And then there's the sort of the middle bit in there. So there is, if we can get more of these small to medium companies growing out to be these larger companies, that's when we start to see a real significant uptick in revenues. Where does this all happen? Well, on the West Island over here, it's mostly New South Wales and Victoria. As you'd expect, not a lot in the Northern Territory. The fact there's even $9 million worth was a bit of a shock to me. A little bit in, not so much in Western Australia. So it's really as usual for any manufacturing in Australia, it's Victoria and New South Wales that have the majority of that. South Australia is primarily based around the defence industry there. And in New Zealand, again, it's the North Island that has the majority of this. That's, again, pretty much standard for New Zealand economics. It's the North Island where all the industry is, and the South Island where all the pretty bits are. And what drives all of this is mainly communications. 50% of all photonics activity that we're able to discover is related to communications in one shape, size, or form. A lot of that is around the design and construction of optical fiber networks. So when you look at these numbers, there's a huge amount of activity in designing and building optical fiber networks and optical fiber componentry. Something like 50% of the GVA and revenue that we saw was related to this. And that's basically because, you know, Telstra is not very large in this. It's the companies that support Telstra, the design companies that support Telstra and the NBN and the construction companies that support them. There's a lot of value add in the photonics space there, where they're installing, they're designing, they're installing, they're rolling out, and they're maintaining optical networks. So when you look at these numbers, half of that is related to the optical communications industry. And that's both in Australia and in New Zealand, which is why you can see there's actually a fair chunk of that in New Zealand. It includes some of the transoceanic cables in that as well. Some of the costs of those are related to here. And as we all know, this slide was put together for a political presentation that we did last year. Basically, pointing out to people who may not be so familiar where photonics sits in relation to the COVID-19 pandemic that we're just hopefully coming out of. And I'm sure people in this room are familiar with this already. UV LEDs for disinfecting surfaces. The PCR testing that everybody is so familiar with these days, basically it's photonics based. You can't do it without photonics in there. Any sort of non-contact thermometry is photonics based. Blood oximeters, one of the major effects of COVID is to reduce your blood oxygenation levels, and that's a critical monitor for patient survival, is making sure there's sufficient blood oxidation. So blood oximeters are really important. Same with bronchial inspection systems, you know, any sort of catheter-based system, photonics-based. But as it says here, the most important thing of all in this has been the internet. If you can imagine being locked down for 6 months without having the internet, with no video on demand, no broadband, think back to, well, maybe here some people who don't remember when there used to be 3 TV channels and that was all you had. That would not have been a great deal of fun. So it's really very hard to imagine how we'd have got through the last 12 months without the contribution to photonics to support surviving and working through this pandemic. As I said at the start, this is the start of a process which will be repeated every few years as we go through and start to try and get a better visibility of photonics within the manufacturing sector as a real industry. The first one, as I talked about, is this ANSIC classification system. So we've got currently 2411, which is photographic, optical and ophthalmic equipment manufacturing. So for us in Silite, we're captured, we're fine. We're ophthalmic equipment manufacturers, we're good. Not quite sure where LiDAR sits in this. And similarly for electric lighting equipment manufacturing. That's the only other place that we see the word photonics or light or anything else appear. So we've got to find some way, and this takes years to decades to change. This isn't something you write to your MP and say, can you please add this ANZIC code for us photonics guys, please? This takes years. This is the most outrageously embedded system that you can imagine in terms of trying to make changes to it. The second one was to improve networking within the photonics industry. This is the perfect example of what is needed there. So again, thank you ladies for setting this up. It is exactly the sort of thing that we need. We need to be getting people from industry, both at the engineering level and also at the management level, talking to each other and creating more visibility to what we do as an industry. At the moment, yeah, we get together, Sydney and I get together for a beer occasionally, and you know we talk about things, but there's no formal linkages, there's no industry advocacy network, there's nothing like that that politicians take notice of. We've got to do better at that. We have to improve the linkages between industry and tertiary education research. We have a much higher education and research base than we do have industry base on a per capita basis compared to other countries in the photonics space. So we're generating a lot more graduates in photonics, do a lot more research than other countries are. And we need to find ways to improve the linkages between industry and university. Now I'll put my industry hat on and annoy all the academics who may be listening in and say, part of the big problem here is that getting academics to commit to deliver anything, to commit to deliverables rather than to just go and have fun following their nose doing research. I know I used to be one. I was an academic for 15 years, so I can say that and expect the bricks to come flying. And I understand, you know, it is important for academics to be able to follow their nose. You know, we wouldn't have the urban dope fibre amplifier if we hadn't been playing around in the lab doing things we weren't supposed to do. But we also need the balance of that, which is the ability for universities to work more closely with industry, to understand the timelines the industry has to work on, which are often very much shorter than anything the university is used to dealing with, and be able to be reactive to that. It's a really hard problem. We've been saying this for years. It's not going to be improved by me saying this. I'm just saying we still have to keep working on that one. And finally, as part of coming out of all this, we need to develop a strategy for the industry. We don't have any overarching view of how the photonics industry works, given the outcome of what's happened in COVID and what's starting to happen now as we come out of that. What we're seeing is that global supply chains are going absolutely crazy. If you try and get hold of certain semiconductors now, you're on a 9 to 12 month wait, which is just impossible if you're trying to get product out the door. And I see Luke nodding his head there, he's going through this as well. It's just crazy. We don't have a sovereign capability in optics or a strategic vision of optics anywhere in this country. It's going to be very hard for us to have a complete sovereign capability in there because there are so many different parts of it. But we need to get our act together to get government support in certain key areas if we can clearly identify them as a whole industry, not just as individual companies putting their hands up for more money. Okay, so finally, to summarise, and I think I'm pretty much on time here, we've got about 600 companies in Australia and New Zealand in photonics. We've got 12,000, not 1,200 people working in photonics, roughly, contributing about $5 billion a year, about half of that in the telecommunications space. It's about 1% of manufacturing output and employment. So it's, you know, it's not zero, it's not 10, 20% as you'd like it to be, but it's reasonable, I think. And I think if we can get our act together over the next few years, and this isn't going to be we'll start now and by September we'll have this nailed. We can get a strategic industry base which can continue to compete in global markets in very specific niches. We're not going to be, the world's greatest manufacturer of diode lasers or anything like that. We will have niches where we will be able to compete and to win in the way that Finisar has done, for example, in wavelength selective switching. Okay, I'm going to stop there. Say, if you want to have a look at more of this, it's online. There's more details and more data inside this, which you can download online. I've got a couple of copies left here. And thank you. I'll take questions now. Thanks very much.
All right, thank you very much, Simon. Are there any questions on the floor for Simon? All right, I'll go here.
So in your study, did you count startups which are in a pre-revenue stage?
Yes, we did, but you don't get much value for those. You just get the employment value that's in there.
So Baraja is in there?
Baraja was in there. This was 2019. And I think Baraja was probably about 50 people at that point. 25, was it even less than that? So yes, it would have been in there, but at a fairly low level. Startups is always a really difficult one because you can argue they're net negative because they don't actually produce anything. They just burn money and spend money. Nothing personal. I know because I use one. Yeah. There's a question here.
Oh, sorry. So
I represent research, so I work at the Australian National University, and I work, so I get money from ARC linkage grant, and I know the problem.
Fantastic.
Yeah. And I have question about, like you said, what was the problem with, we have very developed research in Australia. So a lot of publication in photonics, and each publication in introduction has some application, but it's a very vague very often. And it dies with these publications, never goes to this application. And I can tell what's the problem, to my opinion. You said like a research should deliver something, but the problem is that we deliver publications because it how we evaluated by ARC, by university and by government.
Yes.
And the thing that, for example, I work at linkage grant, and the problem that it's with company, we need to produce product, but what happens, it's a competition of ideas in publication. You have an idea, you have very raw experiment, very simple showing for industry so far, they cannot use it, but you cannot publish it second time if you developed it.
Yes.
So, and you do next. And I remember my supervisor said, forget about this, next idea, next idea. We don't care about this because it's how we evaluate it. Yes. And in linkage project, what's happening for 3 years, I can do 1-2 publication because it based on the idea published already. And it's finally end of my academic career because I want to promotion. They care only about H index, how many publications and so on.
Do you see the I index fallen out of favor now then as well?
Sorry, yeah.
No. It's just H. Yeah.
No, yeah, but this is what my question, do you see how to explain, because they want that research start to deliver application, but there is no this connection. I work and I see that this is a problem.
Yes, look, that's a really great summary of the problem. The problem being that academics are rewarded for publishing. It's fantastic. Yes, that's exactly the problem. And it starts right at the top. A couple of years ago, I went through and looked at the job descriptions and KPIs of several of the leading university vice chancellors, just to see what they were supposed to be doing. And not one of them had anything about industry linkage or industry outcomes in there. It was all about academic excellence. And as you're right, if you step back out of the publishing every 3 to 5 months sort of life that you have to do as an academic, getting those publications in Nature X, whatever X is, getting your H index up above 120 or whatever the cutoff is these days, then you're not going to, if you try and step back from this, okay, I want to do something that has a real use and take it beyond what in academia is all about doing something once and doing it, say it works once, prove that you can do it and then move on to the next one. Whereas industry, it's about making something, then proving it continues to work for the next 30 years and then moving on to the next thing. So it's a very different, you don't want the same peak level of performance, you want a level of performance that's manageable. So it's two very different mindsets, and it's about changing the university mindsets from just pure academic, and it's driven all the way down in all of the way that universities are reviewed, all the way that academics like yourself are reviewed and promoted, all the way down. It's driven by this publish or die, publish or die. And as you said, the competition of publications, fantastic way of thinking about it. And until we can get that change, get to the point where, like in the US, an academic can take a few years out and then come back in again to the same position, then go out do a startup, yes, no, successful, who knows, but then come back in and bring that expertise with them. That so rarely happens in Australia. The number of academics who have really gone out and come back in again is very, very small. Those are the sort of people we need to be finding as role models. Say, look, it is possible to do. These are the guys that we need to be supporting. And we need to change the structures to do that, and it's bloody hard. You know, the university's getting creamed by the government with efficiency dividends and all sorts of other crap. It really doesn't help in that case. So I totally sympathise with where you're at, and know that, you know, you can't change the system. The system has to change as a whole to be able to support this sort of work with universities. Hello, Helen.
Hi.
Actually, I'm just thinking back to the days when I was a student listening to Simon, fresh from the ORC, Southampton, talking about, you know, all the excitement with optical fibres. And now I'm still listening and learning it. So
Oh, God, you're making me feel old.
The years in between. I think there's a few exceptions to the rules about what you're saying about universities, but on the whole, I don't.
Yeah, you can always find these exceptions.
That perhaps they prove the rule. But my question is actually about Australia's contribution to the photonics industry in comparison to other countries around the world. So you said 10 trillion.
Yeah.
How do we perform compared to other countries?
Okay, well, 10 trillion is say that's a global overarching thing, and I don't know if I've got the numbers in this more detailed one in here in terms of how we do compared to other countries. Yeah, off the top of my head, we are fairly similar in terms of the sort of per capita on communications in first world countries. So look at the EU, US, that sort of level of per capita photonics for communications about the same. We're behind significantly in the componentry space. We have no indigenous componentry whatsoever. So we're sort of, you like to say, oh, that's great, we're slightly higher up the food chain, but we don't have that sort of full vertical integration that you would get. And I think if you compare to Europe or the US, Japan, and probably China, we're significantly lower in terms of our per capita photonics output from industry, but at least as good at, if not higher, in terms of our output in terms of publications in photonics.
I'm afraid I'm going to have to interrupt with the online question. So we're
Sure.
a true hybrid meeting. Question about supply chain management. Australia and New Zealand are typically quite far from the typical supply chain path, thinking China, Southeast Asia, and the manufacturing sector. Is this a problem in general for mass available products? Any comments on logistics considering the above?
The answer is, so the question, just to clarify, is because we're the last but one and last bus stop on the planet, does that make it hard for for us to manage the flow of materials and supply chain here? The answer is it's no further from China than Europe is. So we're not that much further. And it is possible, and in fact, it's essential that you are sourcing materials and components at the best quality and the best price you can. And for photonics components, a lot of that now comes out of China and Southeast Asia. The quality of componentry coming out of there over the last couple of decades has increased dramatically. And so you just have to put the time and effort into doing it. It's like the opposite of building a global business. When you're selling globally, you're building a global business when you're buying globally as well. And it requires the same degree of effort and focus to do that. I don't know if you want to comment on that, Luke, from where you are these days.
How do you do it? China uses a lot of the best optics and components.
Yeah, there's exceptions. There are certain other players around the world, and you know, if you want actives, you don't go to China necessarily. It's a bit of a.
Can I ask you another question?
Yes.
From your study, did you have a sense of the amount of R&D that is actually carried out within the Australian photonics?
Yeah. So the question is how much did we determine R&D intensiveness of the photonics industry? The answer to that is no, we didn't dig down into the numbers. We had to go through 600 or about 800 companies and try and work out what proportion of their activity was that, and then to try and slice and dice that down to another level of what was R&D was very hard. I would say that in photonics, generally the R&D component is larger than in other industries. Certainly from the pure manufacturing side. For the value add in terms of network design, there's not a lot of R&D in there. You can say that the design process is R&D, you can argue that that is, but it's really following known rules. So that which is half of the business is probably sort of less R&D intensive. The
reason why I was asking is coming back to your statement about having more collaboration, of course, across industry and academia, is that it's absolutely true that indeed from the academic side of things, one should start looking at a little bit at higher TRL levels, but also there has to be a middle ground where on the other side, the R&D levels can come down enough where you can have a handshake.
Yes.
And I was just wondering, how big of an opportunity is there for doing that?
Well, if you scratch sort of any of us who've done work with universities, you'll see there. You also know there are examples which work really well, and there are examples which you wonder why on earth you walk through the door on a Monday morning. And I've been on both ends of both of those at different times, and so it really comes down to the people that you're working with and the quality of those people and their willingness to engage on both sides. Because it's not just about universities needing to change their game. People in industry need to understand, and I think that a lot of people do because a lot of us come out of a sort of fairly academic training, understand that you can't go in there and demand something by next Friday out of a university in the same way that you could out of your engineering department. You have to set in place things that are slightly longer term. I believe that universities should work with industry on things that are not critical for the industry, long-term important things which are strategically important but not important for this generation of product, might be for the next generation or the generation after that. That's where we should be getting the interaction. Easy to say, really hard to do.
Yes. All right. Unfortunately for time, we're going to have to end it there. We do have 10 minutes of networking, so if you have a burning question, you can find Simon yourself.
Okay,
so before we split, we do have a small token of appreciation. Thank you very much, Simon, for your time.
My favourite. Thank you.